Right, shaft is out. This is the old girl right here.
This is the two fucked bearings. So as you can see, now that we've got that out, changing those would be quite easy. The problem that we've got is obviously the moisture's got in there in the first place. I'm pretty confident it's not the heat exchanger. We're pretty sure it's the seal coming from the stator rotor housing, so in behind here. And we've got part of it apart, but there's a rubber seal in there that at this present moment in time I don't know how it comes out. Right, it only took 3 men, 2 hammers, hammer and the rest of it, but the heat exchanger is off.
And 5 litres of WD-40.
And the stator housing is finally coming off the centre shaft. Literally coming off the centre shaft.
So there's that.
Which finally gives me access to this lip here, which is where the ceramic seal seats. Now you can see we've done a lot of damage to that, which we didn't need to, but that's alright. That'll clean up well enough. We've got enough surface there to still do what we need to do. Excellent. Right, so here we've got the shaft from the centre, which is bare now. So I'm able to measure up with some verniers the 2 bearing diameters, obviously on the shaft and in the housings. This is like the centre column, right in the centre of the brake. So this is the rotor end, that's the sort of input shaft end. Just been basically starting to drag some of the crap off. You can see these holes around the edge here, which were all completely blocked. The idea of them is obviously the mechanical seal should be in here, and theoretically no water should end up that side. Obviously you've got a bearing there and a bearing there, so you don't want water in there because it's going to bugger the bearing. So the idea is if any water does go past that seal, you run out the holes, runs down the casing and just drains out the back through a little hole, which it wouldn't have been doing because they were completely blocked up, but the bearings were, safe to say, shot. So some serious cleaning up here. Obviously you can see I've damaged, just damaged that seat slightly there, trying to get the thing apart, but not too much of a worry because this is literally just the outside of this is like the stationary part of the mechanical seal. So I'll just get a die grinder and just bring that back flush and then really clean the rest of this up, and then we need to start cleaning up the other components. Okay, so this part here is your heat exchanger. So what you can see here is the rotor end. So basically the rotor housing goes on the top here. It then circulates water, so the water comes out the centre here, passes past the brake, returns along these edge things, and is then sent down here. It's then sent around inside this pack of copper pipes, basically, returns through here, and then which then comes out the centre of the rotor again, or stator housing. And then obviously these pipes here are fed from the other side. The 2 halves there. That's the cooling water that is pumped around and around continuously. There's a thermostatic control on each brake, mechanical, which holds a fairly stable temperature inside the brake. So that's what keeps the basically that is basically what takes the energy away, because at the end of the day you're effectively putting all the energy of the car into the brake, which creates heat. So, you know, if you're putting 100 kilowatts into it, you're effectively putting 100 kilowatts into the thing. Obviously not entirely, because you're losing stuff across the bearings, etc. as well. But most of it's going out as heat, so it goes through the coil there and into the water and into the tank. Obviously I've still got repairs to make to the stator on this one, much like we did on the other one. This one's a little bit worse, however I'm pretty confident we can build this up and get it looking pretty good, really. Again, I'm thinking of dropping all of these in electrolysis bath. I've never tried it before, so that'll be a bit of a new thing. To try and get it back to bare metal, just try and stop some of this corrosion, and then we'll try to make sure the water we put in it is nice and clean with antifreeze or whatever in it. Can't beat a bit of a wire wheel. Right, I'm doing a bit of work this evening, just making sure this water pump is sort of working. So it's a centrifugal, fair size pump actually, input on the edge, output on the top, with a 3-phase motor on the side of it, and then we're single phase here, so we can't run the motor directly without sort of a VFD. We also want to be able to vary the speed of this motor, because part of my control plan is actually going to be varying the pressure. So we're going to be driving it with a fairly generic VFD, straight from China. So yeah, I know I always ramble on about Chinese shit. I'm hoping that for what it is, it will do its job. It's not something that's going to be on all day long, sort of continuously. We'll see how it goes. If we get trouble, we can change it, but I'm fairly confident that's going to do the job. So at the minute it's wired in star for 415 volt 3-phase. So I'm just changing it now to run in delta 240. So it basically involves moving the jumpers around. So instead of having a star configuration with, you've basically got 3 poles in the motor. Normally each side of all 3 poles are joined together, and then you put your 3 phases on the other side. We're going to be changing that so they're in like in a different configuration effectively. So I just need to move these jumpers. I'm then going to power up the VFD, and we should be able to get the motor to run. Just give 240 single phase in, 3 phases out, and then we'll be able to control on and off direction, which we don't need, and also the frequency, which therefore affects the speed remotely via a 0 to 10 volt input, which we can control either via computer or, for the time being, just a little variable resistor to give us our adjustable speed. I'm here doing this, I'm not sure what Chris is up to over here, but screw in his mouth, and that screw there is looking like
She hasn't gone in yet.
she's going in. The angle of attack is interesting. I believe he's remounting, oh, I'm looking all over the place here, remounting the heating system up the top, ready for the winter. Now that the bottom end paint project is finished. The heating system was fully mounted down there before, and now it's coming up here. Right, been doing a bit of fiddling. We had some problems in that I wired it up and it didn't work. It tried to go very, very slightly, but you could just tell something wasn't right. It was like it was out of phase, or it was fighting with itself. So turned it off. Did a little bit of research. Turns out on these drives you can set for the amount of poles the motor has, which does make sense. Now this motor in particular is a 2-pole motor because it's a fairly high RPM, 2900, and I went through the settings on the little screen, and sure enough it's set to 4-pole. So I've set that now to 2-pole. I've also limited it to 50 Hz, which is what we run here in the UK. It's capable of running 400 Hz, but obviously the faster the more you turn that up, the faster the motor will run. I only want it to run at the sort of manufacturer speed. So hopefully now, if I press the run button. Oh no, sorry. There we go. You can see it bringing up the frequency slowly, and it should stop at 50, which is where I've set the limit. There you go. Full speed. I don't want to run it dry for too long. Press stop, and it will slowly bring the frequency back down and shut the motor off. So I'm pretty pleased with that.
Full one. Fucking hell.
Looks like I need to put a clamp on every joint, I think.
Right, well, we got a bit of water in the bottom. Darren's going to fire her up.
Just got it returning in the tank, so we're going to do a bit of this is really a pump test, make sure the pump works, and get a bit of idea for pressure and flow. Oh shit, it's just throwing that trip in there again.
Right, she's running. Slight issue, we had to bypass the RCD. Fair flow? Oh yeah. Oh, she's a beauty.
Oh, I can't see any leaks on the shafts here.
Spot on.